At 8:30 a.m. on March the 7th, 1944, Vice Admiral Jizaburo Ozawa stepped on the observing the sunrise over the anchorage at Linger Roads off Sumatra from the bridge of the aircraft carrier Taiho. The ship beneath him symbolized 16,000 tons of steel, 32 months of labor, as well as the Imperial Japanese Navy's last hope. Japan's sole purpose-built fleet carrier was Taihaho, had been in service from the start of the conflict. 32 months with a single carrier. Ozawa possessed 3 days prior. Intelligence reports were obtained. In that same period, the Americans had put 17 new fleet carriers into service. Pause. 17. And the smaller ones were no longer counted. The figures were illogical. They went against all Ozawa knew about construction, shipyard restrictions, and industrial capability. Schedules. Japan had been developing the world's best carrier force for decades. It was said that Americans had started from nothing. However, in some way, in less time than while American shipyards were producing new carriers every month, it took Japan to construct one Taiho. Ozawa understood what those figures signified something. They meant that the war was already lost by Japan. For 16 more months, the gunfire would go on. There would be thousands more guys killed. However, shipyard welding torches, steel, and mathematics determined the result. 7,000 miles distant. It was a straightforward question that kept Ozawa up at night. How do they? With the strongest carrier force ever gathered, Japan joined the war. 2 light carriers and 6 fleet carriers, all up to date and proven in combat. There were 4 in the American Pacific Fleet carriers. Japan was better in terms of numbers, strategy, and 2 decades of developing the carrier doctrine. Since 1922, the Japanese Navy had been constructing carriers. No other navy in the world had a deeper understanding of carrier operations. They had the best trained pilots. Their planes were validated in combat. Years of fighting in China helped them hone their strategies. There was no testing of American carriers. The pilots from America lacked experience. U.S. policy was theoretical. Japan should have dominated carrier warfare for years, according to theory. However, paper lies. By December 1941, Japan realized it had a serious issue: the United States. The industrial capacity of states was 10 times more than that of Japan. Unprocessed steel output, capacity of shipyards, and manufacturing of machine tools. America was favored in every way by ratios that were seemingly insurmountable. The fact that Admiral Isoroku Yamamoto recognized this superior to every member of the Japanese High Command. He had been in Washington as a naval attaché. He had observed American industrial infrastructure, American shipyards, and American factories. Japan might win fights for 6 months, maybe a year, he informed the Japanese leadership. Then, anything Japan might generate would be dwarfed by industrial power. He was disregarded by the government. They thought steel could be defeated by spirit. They thought numerical superiority could be overcome by tactical skill. They felt they had an advantage over factories because of Japan's warrior culture. They were mistaken. The Japan lost its first carrier, Sho, when it was sunk on May 7, 1942, during the Battle of the Coral Sea. After receiving 7 torpedo strikes and 13 bomb hits from American carrier planes, she went down. The 11,000-ton light carrier Shoho was formerly a submarine tender. She transported 30 planes. Although her loss was substantial, it wasn't disastrous. Japan lost 4 fleet carriers in a single day at Midway a month later. Gone, Akagi, Kaga, Soryu, and Hiru. The sun went down by American dive bombers during a 6-minute battle. Those 4 carriers symbolized 2 decades of Japanese naval advancements. 40,000 tons of fighting power that cannot be replaced, and 250 airplanes. As soon as the news reached Tokyo, the Japanese Navy officials started doing calculations, deadlines for replacements. The construction of Akagi had lasted 4 years. Kaga had taken 6 years. It took 3 years for Soryu. It took 4 years, average time spent building. 4, and each fleet carrier lasts for 4 years. There were 4 ships lost. 17 years of building time to swap them out. 3 sizable shipyards in Japan were equipped to construct fleet carriers: Kure and Yokosuka Naval Arsenal, and Kobe's Kawasaki Shipyard. All 3 were exerting their best effort. increasing the ability of merchant ships, cruisers, destroyers, and submarines to replenish combat casualties and aid offensive activities. 4 carriers would need to be replaced, requiring all out for almost 6 years. Just 3 yards were used for carrier building. Thus, there would be no cruisers, destroyers, or no merchant ships, no submarines. That was beyond Japan's means. The conflict was necessary, everything. A decision was taken by the naval staff. They would construct a single new fleet. Prior to Pearl Harbor, the carrier Thach was laid down. They would transform seaplanes and cargo ships, offers to light carriers. They would create a brand new line of more affordable, smaller carriers that could be constructed more quickly. On paper, the proposal seemed logical. The Thach would provide fleet carrier capabilities. The conversions would offer temporary substitutes. The recently introduced Unryu class, Japan's numerical strength would eventually be restored by carriers. It was a well-thought-out, rational plan. Well-resourced. It was a total failure. The keel of Thach had been laid. July 10, 1941. The launch date of the ship was April 7, 1943. On March 7, 1944, she was commissioned 32 months after K laid to commissioning. In fact, for a Japanese fleet carrier, that was swift. In late 1937, Shukaku and Zuikaku established taken at 44 and 45 months, in that order. Japan's carrier has improved. Building schedule considerably. 32 months was a noteworthy accomplishment. On December 31, 1942, the USS Essex was put into service by the Americans. 20 months prior, on April 28, 1941, her keel had been laid. The Essex was bigger than Thach. Compared to Thach, she moved 27,100 tons of standard weight, 29,300 tons. Compared to Thach, who carried 75 aircraft for 20 months, she carried 90. The Americans had constructed a bigger, more powerful carrier in 37% less time than the quickest in Japan, program for construction. However, that wasn't the startling aspect. The startling aspect was Essex was only the initial one. January 1943, Lexington was commissioned, followed by Yorktown, Bunker Hill, Intrepid, Hornet, and finally Franklin. The Americans had commissioned 11 Essex-class ships by December 1943. Carriers 11. Japan put one carrier, Taiho, into service in a single year. In the Tokyo Naval Staff reviewed the intelligence reports in 1944. They looked the numbers over and over. They believed that American propaganda was exaggerated. Manufacturing numbers. But it was verified by spy planes. Photographic intelligence verified it. It was confirmed by intercepted radio traffic. The more quickly than Japan could train pilots to fly from carriers, Americans were launching them. How? The response began with Henry Kaiser was a guy. Prior to 1941, Kaiser had never built a ship. He worked as an engineer for construction. He constructed the Hoover Dam, roads, bridges, and dams, the Grand Coulee Dam and the Bonneville Dam, two enormous concrete constructions that needed organizing thousands of personnel and moving mountains of goods. The U.S. Maritime Commission required cargo ships in 1941, hundreds of freighters, cargo ships number in the thousands, ships to transport fuel, food, troops across the Atlantic and Pacific, ammunition, tanks, and airplanes. According to traditional shipbuilding, it would require a cargo ship takes 6 months to build. That was typical. That's how shipbuilding worked. You installed riveted steel plates on a keel that was constructed from the bottom up. Together, they put in engines, launched the hull, and then worked for 6 months on each ship to build the interior. The Maritime Commission required 2,000 ships. It would require a millennium of capability of the shipyard. Kaiser took a different approach to the issue. He failed to notice vessels. He noticed buildings, steel constructions that could be disassembled into parts that were already manufactured in distinct facilities which were subsequently put together at the shipyard. Rather than constructing ships piece by piece from the bottom up, Kaiser suggested using parts that were welded together to construct ships. Conventional shipwrights insisted it couldn't be done. The technology of riveting was proven. Welding was dangerous. Welded joints may not hold up. A ship could be split in two by cracks that spread through the welds. Kaiser agreed to take the chance. He constructed 4 shipbuilding facilities on San Francisco Bay in Richmond, California. He employed personnel from throughout the nation. The majority had never seen a ship. A large number were female. Numerous were African Americans who had been denied employment in shipyards. Experience didn't matter to Kaiser. He was concerned regarding organization. He separated the building of ships into modules. Every module was constructed in a different prefabrication shop. Bulkheads, engine parts, and deck sections, chambers, superstructures, everything disassembled so that workers could assemble it with just the knowledge of weld that particular component. Because the modules were constructed either upside down or on their sides, welding was made easier. Simplest. With enormous cranes lowered into place and welded together, they were carried to the shipway. The initial took Kaiser 196 days to build the Liberty ship. It took 45 days on the 10th. By 1943, Liberty ships were being completed by Kaiser's yards in 42 days on average. 4 days, 15 hours, and 29 minutes was the record. Robert E. Peary's SS was constructed as a PR stunt to show what was feasible in November 1942. 4 days to construct a ship. Conventional shipwrights had stated 6 months. The method was effective. For freighters, would carriers be able to use it? Kaiser suggested changing his processes to produce escort carriers. Small carriers constructed on commerce ship hulls are intended for ground support and convoy protection rather than fleet activities. The Navy didn't believe it. Carriers were complicated. They needed skilled labor, specialized equipment, years of experience. Give him a chance. Kaiser's Vancouver, Washington. On November 3rd, the shipyard laid the keel for the escort carrier Casablanca, 1942. The debut date of the ship was April 5th, 1943. Put into service on July 8th, 1943. From keel until commissioning, 8 months. The 50 escort carriers were desired by the Navy. In just 14 months, Kaiser provided 50 carriers, 1 carrier every 8 days. These reports were sent to the Japanese Navy staff in Tokyo and thought they were mistakes. Physically, 1 carrier every 8 days was not feasible. It went against all the rules of building ships. However, the claims continued to come in, and they were verified by battles. American carrier task forces by the end of 1943 were showing up in the Pacific with numbers that were tactically illogical. 12, 15, and 18 carriers in a single task force. There were 6 carriers in Japan's total fleet. The task forces bigger than Japan's whole carrier fleet were being deployed by the Americans. Where were these ships arriving from? From somewhere else than Kaiser's escort carriers? The fleet carriers of the Essex class included reaching the squadron level. The same prefabrication method used for fleet carriers was the key: building. Since the 1930s, Virginia's Newport News Shipbuilding has been producing carriers. They were aware of carrier building. Although they were aware that it takes years, they took a cue from Kaiser's cargo ship techniques. They began assembling carrier parts in advance. Flight decks, hangar decks, hull sections, island superstructures, each constructed in a different shop before being transported to the shipway for final assembly. They, wherever possible, weld instead of rivet. Faster welding was necessary. Lighter constructions were produced using less specialized labor. Their designs were standardized. All Essex-class carriers employed identical blueprints, identical components, and identical apparatus. After learning how to construct one module, workers proceeded to construct numerous identical modules. They made building sequences more efficient. Rather than waiting to begin the following part until the previous one is finished, several portions were constructed concurrently in various sites before being combined. The USS Franklin constructed on December 7, 1942, at Newport News. On October 14, 1943, it was launched. Put into service on January 31, 1944. From keel until commissioning, 13 months. The record wasn't even that. Numerous in 14 to 16 months, Essex-class carriers were finished. 18 months was the average. Thach, Japan, took 32 months. Fleet carriers were being built at American shipyards. They were constructing more than twice as many ships and doing so twice as quickly as Japanese shipyards. As soon as Thach was, when the Americans put their 17 Essex-class carriers into service in March of 1944, They had 17-to-1 for in-service or under construction. The ratio deteriorated when you added both the escort and light carriers. Over 100 carriers of different kinds were in operation in America. By the middle of 1944, Japan had 9. The Japanese Navy made an effort to adjust. 14 unrelass were ordered. Carriers. These were made for mass production, were easier to construct, and were smaller than Taihaho. The class of Unru was built on the Hiyu design from before the war, but updated with tried-and-true technology and common parts. They moved 17,150 tons, capable of 34 knots, and able to carry 6.5 aircraft. They were intended to be the equivalent of the Essex class in Japan. 3 were finished. Katsuragi Unryu Amagi. The commissioning of Unryu took place on August 6, 1944. August 10, 1944. Amagi. On October 15, 1944, Katsuragi. In 10 weeks, 3 carriers went into service. It appeared to be advancement. Japan was producing more carriers. Unless the Americans ordered 9 within the same 10-week time frame as Essex-class carriers. The Japanese were unable to keep up. The Americans always accelerated more quickly than they did. Even worse, Japan's resources were running low. Steel is needed to build a carrier. Tons of steel. A carrier of the Essex class carried about 27,000 tons of armor plate, structural steel plate, and steel plate. The U.S. generated 60 steel production, reached 80 million tons in 1944, up from millions in 1943. In 1943, Japan produced 8 million tons. In 1944, 6 million tons. 10 times as much steel was being produced by the American steel industry as the whole industrial capacity of Japan. Every element was affected by the steel gap of building ships. Steel was produced at American shipyards. They could construct machines, armor, and hulls, all they required. They replaced any broken or improperly constructed sections with new ones. Steel was restricted in Japanese shipbuilding. Each plate was valuable. Errors had to be repaired rather than replaced. Due to time spent on repairs, construction delayed. Mistakes rather than continuing. Lathes, drill presses, milling machines, and other machine tools were available in American shipyards, all powered, up to date, and ready to perform precise job quickly. Japanese restricted machine tools in shipyards. Many were deteriorating, aged, and worn out. There were few spare parts. Due to equipment failures and personnel waiting for repairs, production slowed. Welding equipment was available in American shipyards. Oxygen acetylene torches, thousands of welding stations, standardized and maintained electric arc welders. Welding at Japanese shipyards was restricted. Apparatus. Due to a lack of adequate welding capacity, many yards continued to utilize riveting. The distance reached skilled laborers. By 1943, 2 million people were employed in American shipyards. They were swiftly trained using standardized procedures and easy repetitive jobs, even though many of them were new to shipbuilding. At their height, Kaiser's Richmond shipyards alone employed 90,000 people. That was more employees than together, the 3 largest naval shipyards in Japan. The workers in Richmond didn't resemble conventional personnel in shipyards. Women made up 40%. Many had never participated in industrial positions previously. They were professors from small towns, Midwest farm spouses, office workers from American cities. After 2 weeks of instruction, they were able to weld. They discovered how to run cranes in 3 days. Within a week, they were able to read blueprints. These people couldn't possibly build high-quality ships according to traditional shipbuilders. They did not have the years of precision metal work requires experience. However, Kaiser's prefabrication technique didn't need time to experience. Workers who could perform a single task accurately and repeatedly were needed. One of the Richmond welders' ship architecture was not required to be understood by yards. She had to understand how to weld a certain kind of seam on a particular kind of joint. She could see where the fixtures and jigs were located in the plans. Kept everything in place. She proceeded to the next piece, welding the same joints dozens of times each time. Change. Expertise was developed by repetition. A month later, workers grew nimble. 2 months later, they were accurate. They may work more quickly after 3 months. Compared to conventional shipwriters who had studied their craft for years, This model was impossible for the Japanese to imitate. 300,000 people were employed in Japanese shipyards. Many were expert artisans. However, they were overburdened with dozens of projects. It took longer to train new hires since seasoned employees were too busy to instruct. Furthermore, Japanese industrial culture prioritized craftsmanship above uniformity. Each item was expertly fitted by a Japanese ship fitter who takes satisfaction in making little modifications to guarantee flawless alignment. That method was slow, but it created magnificent ships. Nothing was custom fit by American artisans. Parts were produced in accordance with exact specifications in shops for prefabrication. Either they were compatible or they weren't. If a portion was rejected since it didn't fit, and a new one was created. That strategy produced ships that are quick and functional. The philosophical differences were a reflection of the differences in industrial capability. Japan has few machine tools, few steel resources, and few employees. Each component had to be utilized. It was not acceptable to waste. Personalized fitting made certain that nothing was wasted. America possessed a wealth of machine tools and steel, lots of staff. They manufactured another component if the first one was incorrect. Speed was important, greater than flawlessness. Although both strategies had advantages, speed prevailed during a war. There were enough American labor for them to specialize. Bulkheads were built by one crew. A different team constructed the deck. Sections, propulsion equipment was fitted by a different crew. Expertise accelerated velocity. Japanese shipyards required people with a wide range of skills. Ship fitters have to install and fit hulls, operate electrical systems and machinery. Generalists were slower but more adaptable. The majority of Essex-class carriers were constructed at the Newport News shipbuilding, which created dedicated assembly spaces for various carrier parts. A 500-foot-long structure was set aside for solely to the fabrication of flight deck components. Steel plate was transferred from storage racks to stations for cutting plates, according to standards using acetylene torches. After being cut, the plates were taken to edge preparation stations, where welders beveled the edges. Next to jigs for assembly, where the plates were tack welded together after being aligned. Lastly, we went to welding stations where groups of welders permanent welds that operate sequentially. Every welder is in charge of a certain section. It took 8 days to finish a 120-foot-long by 90-foot-wide flight deck portion, from unfinished steel to the final part. The identical portion was constructed with a single team and conventional procedures. It would take 6 weeks to work in the shipway. Elevator assemblies were manufactured in another facility. Elevators used by carriers were intricate hydraulically driven devices that could raise a 30-ton aircraft from the hangar deck to the 30 seconds for the flight deck. Elevators were installed in the carrier hull piece by traditional shipyards. It was a challenging task in confined areas that calls for careful alignment and a great deal of testing. Newport News constructed complete lift assemblies in a separate facility. Testing was done on the assembly. Before it ever made it to the ship, it was modified and checked. At the moment of installation arrived, cranes raised the entire lift into place. It required days to connect to hydraulic systems instead of weeks. Similar consideration was given to propulsion systems. Each class's carrier required 8 boilers, 4 sets of turbines, reduction gears, and propellers. Thousands of feet of steam piping and shafts. It used to take months to install this equipment. Newport News assembled propulsion module components. Each module included 2 boilers, a full turbine set, and all pre-assembled and tested related pipes. The modules were constructed in a different building that was fully furnished. It includes controls and instrumentation. Temporary steam was used to test fire them. Links to confirm functionality. Cranes hoisted the complete propulsion module into the ship hull when it was completed. The area for the machinery, electrical wires, control systems, and steam lines were linked by workers. The complete installation only 3 weeks as opposed to 3 months. This modular strategy was expanded to everything. Radar systems were tested and pre-assembled. Complete radar towers equipped with transmitters, antennas, electronic businesses constructed receivers and power supplies, which were subsequently fitted as units. Accommodations for the crew were prefabricated. Bunks, lockers, ventilation, and lights were arranged in berthing chambers in specialty stores before being hoisted into place inside the hull. Even little things were uniform. Each hatch was the same. Each ladder, each door, each ventilation duct is constructed in accordance with standard requirements and fits into standard holes. Employees didn't. Each item must be measured, cut, and fitted separately. They took prefabricated parts out of storage, fastened, or proceeded to the next operation after welding them into position. Carriers progressed from keel laying to launch in 6 to 8 months, followed by a further 6 to 8 months for trials and outfitting before to commissioning. The entire period from inception to operational carrier is 14 to 16 months. Japan was unable to match this since they were missing 3 essential components. They first lacked the industrial infrastructure necessary for actual large-scale manufacturing. Prefabrication necessitated companies that could precisely manufacture thousands of similar components. Tolerances. Due to decades of manufacturing automobiles and appliances, American industry has that infrastructure. Manufacturing as well as the creation of consumer items. Standardized assembly lines served as the foundation for the design of factories. Components as well as interchangeable parts. The Japanese industry lacked experience in large quantities. The majority of manufacturing was focused on small-scale custom projects. Instead of assembly lines, precision parts were sourced from specialized machine shops. Making an effort to imitate American prefabrication techniques would have necessitated the construction of completely new factories and the training of workforces and creating supply chains from scratch. Japan was pressed for time, resources, or knowledge for that change. Secondly, the basic material was not available. Ability. Prefabrication wastes money. More steel is cut than is necessary. You create components that must be discarded since they don't fit. To make sure you never run out of parts, you overstock them. Kaiser's Richmond yards when they ordered 15% more steel than the ship needed to build the Liberty. The waste, errors, rejected parts, and inventory buffers were all covered by extra steel. That strategy was effective when steel was plentiful. When steel was in short supply, it failed. 15% waste was too much for Japan to afford. Each and every ton of steel plate was valuable. Waste had to be kept to a minimum. Custom fitment was required. Slower work was the result. Longer building times resulted from that. Thirdly, they had no infrastructure for transportation. Because parts could be produced anywhere in the nation and transported to other locations, American prefabrication was successful. Railway shipyards. A flatbed rail car carrying a bulkhead portion constructed in Pennsylvania could reach Newport News in 24 hours a day. It was being welded onto a carrier hull 2 days later. Japan's railway network was constrained. Coastal ships moved the majority of heavy components. That vessel was constantly being attacked through American submarines. It could take 2 weeks for a ship to deliver a turbine constructed in Kobe to Yokosuka. If the turbine was lost and a new had to be constructed after the ship was sunk, which happened frequently, Japanese naval development was plagued by chain weaknesses. More detrimentally than any one aspect alone, the distance expanded to include logistics, electronics, rubber, copper, aluminum, and steel were shipped to American shipyards. Everything they required was transported by truck and rail from factories located around the continent. If there were issues with one provider, there were options. Shipping was essential to Japanese shipyards. Steel was sourced from Korean mills in Manchuria. Mines in the Philippines were the source of copper. Rubber originated in the Netherlands, East Indies. All of them were traveling on commercial vessels that the Americans were sinking, but submarines more frequently. Japan was losing merchant shipping by 1944, quicker than it could be replaced by shipyards. Important supplies were not coming in. Shipyards were waiting on steel plate, turbine blades, and electrical wire, which caused delays in construction schedules. Taihaho was built with 4 turbines and 8 boilers that could generate 160,000 shaft horsepower. 2 of the Katsuragi and ASO, 2 Unro carriers, were constructed with destroyer engines due to fleet ship power plants could not be produced quickly enough by turbine manufacturers. Only 25 knots could be made by the carriers, as opposed to 34 knots. With slower carriers, there was less tactical adaptability and less capacity to close with opposing forces or flee danger, and more capacity to avoid attacks. The Americans did not encounter any similar concessions. The propulsion systems used by each Essex-class ship were the same. No exceptions. 150,000 shaft horsepower at 33 knots. Additionally, the Japanese had to deal with a crisis in pilot training. It was just half the trouble to build carriers. Instruction. It was equally important for pilots to fly from them. Prior to the conflict, Japan possessed the world's top naval aviators. Prior to their first carrier landing, pilots trained for 2 years. They worked on night operations, carrier approaches, formation flying, gunnery, and navigation. By Japan didn't have 2 years in 1943. They were not given a year. American submarine Japanese commerce ships was being destroyed by war. Training flights would use less fuel as a result. Training for pilots? The length of the programs was reduced from 24 months to 12 months, and finally to 8 months. Pilots, instead of 500 flying hours, they were graduating to fleet squadrons with 100. They had the ability to shoot and fly, but they lacked the experience to withstand combat against American pilots with combat experience. Sakai Saburo, with 64 kills, one of Japan's best aces, was removed from battle in early 1943 to act as an instructor of flight. He was taken aback by what he discovered. The instruction, the software, was overloaded. There were too many pupils for the teachers. Classes moved quickly. There was not time to adequately teach fundamental skills, thus they were being bypassed. Later on, Sakai wrote that they were instructed to move men quickly, ignore the details. Simply instruct them in shooting and flying. The pilots who received their degrees were sent to carrier squadrons to complete air groups based on these condensed programs. They were courageous, committed. They weren't prepared, but they were prepared to die for their nation. In June 1944, during the Battle of the Philippine Sea, in opposition to American task forces, the Japanese deployed 450 carrier aircraft. The American 300 of them were shot down by fighters. It was dubbed the Great Marianas Turkey Shoot by the Americans. The conflict showed every aspect of Japanese carrier operations is flawed. In 1944, Japan sent 9 carriers into combat. Taiho, 3 fleet carriers, 6 light carriers, Shokaku, Zuikaku, Chitose, Chiyoda, Juno, Hio, Ryuo, and Unryu, recently commissioned. There were 450 aircraft on board those 9 carriers. That was less than half of what those carriers were intended to carry in terms of aircraft capacity. Japan just lacked sufficient aircraft to outfit its carriers completely. Even worse, the pilots operating those planes lacked proper training. Prior to before their first combat deployment during the war, Japanese carrier pilots trained for 2 years. Pilots by June 1944 were moving to carriers. They were able to take off and land after 6 months of training. They were able to fly simple formations. They had the ability to control their aircraft systems. However, they did not have the combat experience to endure in the face of seasoned American pilots operating better planes. The American task, under Admiral Mark Mitchell's leadership, Force 58 deployed 15 carriers, 7 8 lightships, and Essex-class fleet carriers. Those carriers set out 956 planes, more than twice as many as the Japanese, and those American planes were better than their counterparts in Japan. The Hellcat F-6F fighters maximum 380 miles per hour, as opposed to 340 miles per hour for the A6M0. At 450, the Hellcat could dive miles per hour without any structural breakdown. 360 miles per hour was the Zero's top dive speed. It was an armored Hellcat, armored engine, self-sealing fuel tanks, and pilot armor cowling. It could continue to fly while absorbing massive battle damage. There was no armor on the Zero. One outburst of it would be ignited by machine gun fire passing across the fuel tank. Pilot deaths were disastrous since they lacked defense. Together, the Hellcat's 650 caliber machine guns could fire 1,800 rounds per minute. The Zero was equipped with 2 7.7mm machine guns and 2 20mm cannons. Good weapons, but not as much continuous firepower as the Hellcat. The most important was that American pilots in June 1944 were veterans of combat. Task Force 58's typical American fighter pilot has 200 hours of experience flying in combat. Many have at least 300 hours. They participated in dozens of lesser battles and fought at Tarawa, Thach and Hollandia. They were aware of the capabilities of their aircraft. They were adept at taking use of the Hellcat's advantages. They were skilled at defeating Zeros. Japanese pilots flew in combat for an average of 20 hours. Some didn't have any. They were taking on the biggest and most seasoned naval aviation force ever in their maiden ship operation. Put together, the outcome was expected. Japan debuted its first on June 19th. Round of strikes at 7:30 a.m. MiF-69 airplanes. At 150 miles, they were picked up by American radar. 40 Hellcats were vetoed by fighter directors in order to intercept. The Japanese were struck by the Hellcats. 40 miles from the carriers is the formation. In the first 10 minutes, they shot down 42 planes. Minutes spent in warfare. The Japanese planes that were still alive kept moving in the direction of the carriers. They came across a second wave of American fighters, followed by a third wave, and finally anti-aircraft fire from the cruisers and screening destroyers. 8. The planes entered the carriers. They failed to score any hits. 4 planes went back to their carriers. 94% of Japan's planes were lost in the initial raid. At 8:56 a.m., the second strike was launched. Did not fare any better. 109 aircraft were able to meet the identical, multi-layered defense. Before they could assault, 97 of them were destroyed by American fighters. The third blow, 107 aircraft, managed to hit the battleship South Dakota with a single bomb, resulting in minimal damage. The fourth blow turned into confused. A few planes discovered American carriers but were chased away. Others never found the enemy and brought their bombs back to their carriers. Out of 450 planes, 300 were shot down after being launched. 50 more people crashed while trying to land on carriers. After the fight, in the dark. In a single day, Japan lost 350 planes and their pilots. Of battle. America lost 29 planes. The 12-to-1 exchange rate in America's favor represented the combined benefits of better aircraft, better pilots, better doctrine, and better radar guidance. It also represented the fallout from Japan's unsuccessful carrier construction project. If Japan could have sent 20 or 30 carriers to the Philippines if they had been able to manufacture carriers as quickly as America. C rather than 9. Despite using subpar aircraft and pilots, 30 carriers would have sent out more than 1,000 planes. American defenses might have been overpowered by sheer numbers. However, Japan had 9 carriers, 3 of which were lost by the battle's conclusion. Japan. In that conflict, 3 carriers were lost: Hyo, Shokaku, and Taiho. The Taiho only lasted 3 months after being put into service. The American submarine fired a single torpedo at her, Kavala, on the 19th of June. The harm ought to have been controllable. Japanese harm for torpedo impacts, control doctrine was sufficient, but a novice damage control officer made a crucial mistake. He directed the activation of the ship's ventilation system to remove petrol fumes from the hangar deck. The system of ventilation, instead of releasing the fumes overboard, distribute them around the ship. A spark appeared 6 hours after the torpedo struck, ignited the fumes of petrol. The ship was ripped apart by the explosion. She fell. In a matter of minutes, bringing 1,272 guys along. 3 months of service after 32 months of construction gone. Shokaku, a Pearl veteran and one of Japan's most prosperous carriers in Santa Cruz's harbor, Coral Sea, the submarine fired 4 torpedoes. Kavala. 7 hours later, she sank. Bombs and aerial torpedoes struck Ho. She sank, lost power, and caught fire. In a single day, Japan lost 3 carriers. No Americans were harmed. Japan's carrier force by the end of 1944 was successfully completed. The Japanese used their surviving carriers as a decoy force at the Battle of Lee Gulf in October. To lure American ships away from the main fighting area, 4 carriers with nearly no aircraft on board headed north. The strategy was successful. All 4 carriers were sunk by American carrier aircraft that targeted the decoy force. But the sacrifice accomplished nothing. Later in the Gulf, American escort carriers repelled the Japanese surface fleet anyhow. Japan's final carriers were lost in the deception operation without any strategic advantage. The final of the 6 carriers to assault Pearl was Zuikaku, went down on October 25, 1944 in harbor. She had been in combat for 3 years. She was sunk because Japan lacked the pilots and aircraft necessary to defend her. Japan, by November 1944, had no fleet carriers that are in operating. America had 28. America's industrial edge was structural rather than merely numerical. When damage occurred to an Essex-class carrier, it sailed to a Navy yard for repairs while in combat. The fixes were finished in weeks or months utilizing large maintenance facilities, standardized parts, and prefabricated replacement portions. On March 19, 1945, the USS Franklin was struck by two bombs while cruising off the coast of Japan. After the bombs entered the hangar through the flight deck, they caused secondary explosions from planes that were armed and fueled. Hours passed while the fires burned. There were 87 men slain. With magazines on the verge of blowing up, the ship was listing and dead in the sea. Any other Navy would have ship that has been abandoned. Franklin was obviously disoriented. However, American damage control teams fixed the list, put out the fires, and started the engines. Franklin set sail. She drove herself to Pearl Harbor at 14 knots. She traveled to the Brooklyn Navy Yard from Pearl Harbor for two fixes. It was on April 28, 1945, that the ship reached Brooklyn. She survived, but the war ended before she could rejoin the military. That degree of Japan was unable to control the damage. Major attacks on Japanese carriers sank or were scuttled most of the time. Japan lacked replacement parts, repair facilities, and skilled damage technicians. Control crews to rescue ships that are severely damaged. The disparity between Japanese and American industrial capabilities demonstrated appearing in all facets of carrier operations. Radar was available on American carriers. SK air type. At a distance of 90 miles, search radar could identify approaching aircraft. Height of type SM altitude could be determined by locating radar. Fighter directors vectored interceptors into impending hits using radar. Before to arriving at the fleet, Japanese carriers' radar capabilities were inadequate. Initial models could, in perfect circumstances, identify aircraft at 30 miles. Operations at night and poor weather severely reduced performance. Japanese filmmakers of combat use visual seeing and reports from picket ships via radio. The proximity fuse was used by American carriers, shells that prevent airplanes. The VT fuse detected adjacent objects using a tiny radar. Aircraft, and the shell will automatically explode. The effectiveness of proximity fuses against aeroplanes was enhanced by 5 to 10 times in contrast to time or contact fuses. Japanese carriers made use of time and contact fuse. Shells had to be timed to burst at the proper altitude or strike the target directly. Both approaches were far not as good as proximity fuses. The aircraft on American ships were superior. In practically every category, the F-6F Hellcat fighter could perform better than the A-6M0. Improved protection, improved armor, improved speed, improved climb rate, and improved diving speed. Japanese carriers continued to depend on the Zero, which hadn't seen any major improvements since 1941. Compared to the Hellcat, Zero was lighter and more agile, but it was slower, more brittle, and had less firepower to swiftly destroy American planes that are strongly armored. The United States carriers had superior doctrine. Prior to strikes, fighter sweeps cleared enemy airspace. Fight the Fleet was shielded from approaching attacks by air patrols. Fighters were pulled into combat by radar-directed intercepts. Posture prior to the arrival of enemy strikes. According to Japanese carrier doctrine, the full-scale attack. Start everything, strike the adversary as hard as you can, and hope to, before carriers could retaliate, sink them. When surprise was total, the theory worked at Pearl Harbor. It failed when American carriers were waiting in the middle. When American radar supplied an early warning, it failed in the Philippine Sea. Warning, and American combatants annihilated the approaching attack. The Japanese Navy had successfully ceased to be a combatant force. Japan still possessed cruisers, battleships, destroyers, but those ships were unable to operate in regions where American carrier planes were present since they lacked carriers for air protection. Could get to them. The few Japanese carriers that remained were assigned to cargo or training operations. Because Japan lacks the planes and pilots necessary to run them efficiently, there were more carrier ships in the U.S. Navy, more air power than all other nations' fleets combined. Task Force 38 in operation included 17 fleet carriers and 6 light ships off Japan in July 1945. Carriers. More than 1,500 planes were taken by the carriers. The whole strike, it would have taken less than 2 hours to prepare, launch, and recover the force. Japan had nothing at all to oppose that amount of air power. Airfields were struck by American carrier strikes that flew freely over Japan. Anything that moved, including ports, factories, and naval stations. Japanese air defenses were overpowered. There were 10 or 20 times as many Japanese fighters as there were. The conflict concluded on the 15th of August, 1945. 6 carriers had been put into service by Japan. Throughout the conflict, 3 fleet carriers of the Unru class and 3 converted light carriers. 20 had been commissioned by America. 9 fleet carriers of the Essex class, 4 more than 100 escort carriers, and Independence-class light carriers are available. The last it was about 20 to 1. For every Japanese carrier, there are 20 American carriers, constructed throughout the conflict. That ratio demonstrated how industrial capacity influenced the Pacific's outcome. War. Japan had the best carrier force in the world going into the war, having been constructed over 20 years by the most skilled Asian shipbuilders and naval architects. America brought an unproven carrier force into the conflict, constructed by shipyards that had to quickly learn how to build carriers. But Japan couldn't match what America had: raw materials, technological innovation, industrial capacity, and the capacity to acquire, modify, and expand output to previously unattainable levels. The carrier's lessons. Beyond World War II, the construction race continued. Industrial capacity is more important than tactical skill. In 1941, Japan's carrier doctrine was superior: better planes, better pilots, and better experience in operations. For the first 6 months, they prevailed in every conflict. However, tactical advantages diminish. Pilots lose their lives. Aircraft become outdated. The doctrine changes. Industrial benefits compound. All of America's newly constructed carriers made it. The following one is simpler to construct. Training the next worker was sped up by each trained worker. Each standardized component improved the efficiency of the supply chain. By the middle of 1943, American carriers. The system of construction has become self-reinforcing. Carriers were being completed by shipyards more quickly than they might provide them with crew training. That momentum was never attained by Japan. Each carrier. The resources they built were used for the subsequent one. Training each employee required time away from production. Each part standardized the necessary retooling of already overburdened industries. The disparity grew rapidly. Early on, Japan had 8 active carriers in 1942. There were 3 in America. By the middle, Japan had 6 active carriers in 1943. America had 14. By the middle of 1944, Japan had 7 carriers in operation. America had 32. At the beginning of 1945, Japan had no carriers in operation. 39 were in America. It wasn't a straight line. It was geometric. The strength of American carriers grew, tripled, then quadrupled, when Japanese power decreased. Every naval building category showed the same pattern. Japan constructed 6 fleet carriers throughout the conflict. America produced 24 Essex-class carriers. Japan. During the conflict, 3 light carriers were constructed. America produced 9 light carriers of the Independence class. Japan. During the conflict, no escort carriers were finished. America finished Casablanca's 77 number of different escort carrier kinds in addition to class escort carriers. Complete carrier construction. Japan made 9 carriers during 3.5 years of conflict. America manufactured 110 carriers in the same time frame. It was about a 12 to 1 ratio. Each Japanese has 12 American carriers. Carrier. However, the disparity is actually understated by even that ratio. The American carriers were bigger, could transport more planes, and had superior radar, anti-aircraft defenses, damage control, and everything. 90 aircraft could be flown by an Essex-class carrier. An Unrius carrier, able to fly 65 aircraft. The speed of an Essex-class carrier was 33 knots. A few, even with emergency destroyer engines, Japanese carriers could hardly reach 25 knots. A carrier of the Essex class had thorough radar coverage. Japanese carriers' weak radar frequently malfunctioned at crucial times. Thus, the 12A numerical advantage of 20 to 1 corresponded to an effective combat capability of about 20 to 1. 20 American carriers worth of fighting capability for each Japanese carrier. Because of their superiority, naval combat in the Pacific became biased after the middle of 1944. Japanese surface troops were unable to function, not destroyed, but within range of American carriers. Japanese bases were unable to operate within range of carrier from the United States without being neutralized. Japanese supply chains were unable to operate within the WWII, American carriers that have not been cut off. American carrier aircraft turned the Pacific War into a conflict in which they bombed Japan into capitulation as Japanese soldiers stood helplessly behind ever-diminishing defensive perimeters. By July, American carrier task groups conducted operations off the coast of Japan in 1945 with freedom. They attacked Japanese cities with thousands of aircraft. Japanese air defenses were overpowered. There were 50 more Japanese fighters than there were. The conflict did not end because of atomic bombs, even though those gave Japanese officials a handy reason to give up. The conflict terminated because Japan's military might was exhausted. That capability was removed by carrier aviation, and the carrier aviation that won the war was made possible by carrier production. Kaiser Henry, by using mass manufacturing methods, the dam builder, who had no prior shipbuilding experience, revolutionized shipbuilding. Kaiser taught Newport News, a typical carrier builder, how to shorten construction timeframes, cut in half. Many of the women who worked in Richmond shipyards had never handled a wrench before 1942. In months, transports were constructed that should have taken years. They combined to create a fleet that overpowered Japan by utter industrial might. The Japanese realized their defeat too late. The conflict as soon as they initiated it. The warning had come from Admiral Yamamoto. He claimed that Japan might win conflicts for 6 months or even a year. Then they would be buried by American industrial power. He was right. However, even Yamamoto failed to account for the speed with which American industry would mobilize. He estimated that America would need 2 years to construct replacement carriers for those lost in the Coral Sea and Pearl Harbor. It required 9 months. He predicted that 8 to 10 carriers will be produced annually in the United States. America generated 18 carriers just in 1943. He believed it would take years for American pilots to acquire the abilities of Japanese pilots. American pilots were engaged in combat. Japanese pilots less than 18 months after Pearl Harbor by early 1943. The Japanese were incorrect in all their assumptions regarding the industrial capacity of the United States. Every presumption is undervalued. America's capacity to assemble forces, educate laborers, and manufacture weapons at scales beyond Japan's comprehension. Although the story's title isn't entirely true, it conveys the main idea. Japan, in 3 years of conflict, 6 carriers were built. Depending on how you count conversions, the precise figure varies. Reclassifications, but the generally recognized number for finished purpose-built fleet carriers is 6. When there is a war. During the war, America constructed 17 Essex-class fleet carriers. Years. Since the precise number for the Leo is 17, the Renquadding is. When the war ended, 8 more were being built. These were either finished later or canceled, while 17 understates that the Independence-class light carriers, 17 plus 9 equals 26, are included in the American carrier production. Including all other escort carriers, Casablanca-class escort carriers, 26 plus 77 equals 103. There were more than 130 classes of carriers put into service throughout the conflict. The heading claims that they ceased counting. It isn't actually true. The Navy tallied each and every ship, but the sheer volume made individual carriers strategically irrelevant. By the end of 1944, although tactically regrettable, losing a carrier in battle was not strategically significant. There would be another carrier next month. Japan experienced a national crisis after losing a carrier. They said prayers. There were memorial ceremonies and accusations made against naval officers for failing to safeguard priceless assets. The way that carriers react to losses, both strategically and emotionally, reveals the industrial divide between the two countries. Every carrier was valuable to Japan. When one was lost, it meant months or years to swap out. Every carrier mattered to America. Losing one meant waiting weeks for the successor, which is now being built. That distinction, above all conflicts or any The result of the conflict depended on the tactical inventiveness or the brilliance of the admiral. Industrial capability took first place. The Pacific War. Not bravery, not selflessness, not strategic skill, not warrior assembly lines, steel, welding torches, and spirit. That lesson is still applicable, pertinent to anybody researching international rivalry, strategy, or combat today. In industries, wars are won long before the battlefield decides them. The Japanese knew what was going on. Vice Admiral Ozawa knew the numbers while standing on the bridge across Taihaho in March 1944. He was familiar with Japan, had fallen short. However, comprehending the issue and resolving it were two different things. Japan was unable to expand its shipyards. They lacked personnel, machinery, steel, and logistics. Infrastructure. No more pilots could be trained in Japan. They were without the fuel, the teachers, the moment. Japan was unable to boost its steel output. They did not have iron ore, coal, or the capacity for conveyance. Japanese industrial potential was limited in every way by resources that were running out. American industrial capacity was growing in all directions. By in 1945, carriers they didn't need were being launched by American shipyards. A few following the conclusion of the war, Essex-class carriers were finished. They existed, but they never fired a shot in battle. 32, they ordered Essex-class carriers. 24 were finished. 8 were canceled after the war was over. The 14 Yunru-class carriers that Japan had planned were never built. They finished 3. By the end of the war, 6 more were being built. 5 were never initiated. The distance between both the Japanese and American capacities were substantial. It was absolute. The Pacific War was decided in shipyards, not battles. Battles determined when the war ended. Shipyards determined who would win. And the American shipyards, with their prefabrication techniques, their welding innovations, their standardized designs, their armies of workers who had never built ships before, crushed Japan's naval power through sheer industrial output. The title wasn't wrong. The Japanese built 6 carriers in 3 years of war. The Americans built 17 Essex-class fleet carriers, stopped counting escort carriers after 100, and still had shipyard capacity left over to build merchant ships, landing craft, and liberty ships by the thousands. That disparity, more than any battle, any strategy, any tactical innovation, determined the outcome of the war in the Pacific. If you found this story compelling, please take a moment to like this video. It helps us share more forgotten stories from World War II. Subscribe to stay connected with these histories. Each one matters. Each one deserves to be remembered. We would love to hear from you. Leave a comment below telling us where you're watching from. Our community spans continents. From veterans to history enthusiasts, you are part of something special here. Thank you for watching, and thank you for keeping these stories.